Great, yes. We're live for day 5 of Admin of Code. Um, we have about 15 minutes until we begin, and I thought until then I would just review some of day 4, catch up on what other people are doing with what other people did with day 4 on Discord, and maybe look over what I ended up with as a solution cleaned up here. So, this is I simplified this a little bit by not have returning both sets. We never really need the sets. We only ever need the matches themselves. So I put this into a map. This could also be an array because it's just 1 through whatever. But this means I didn't have to think about off by 1 index. And performance doesn't matter so much here. And this is part 1 right here. It's a one-liner. You just take 2 to whatever that number of matches is as a power. And I went with a mutable approach here, just doing the counts. And for each of the cards, then I'll just add more cards to all the later ones. You can condense some of these into one-liners, but I think this keeps it tight and still legible. But let's see what people have to say about that. Okay, what am I catching up on here? I think uh, I have this cough. I got sick like 3 weeks ago, and I have this persistent cough. I think it's getting worse. Makes it really hard to talk. I'll, I'll live. Oh, 1 second. I just need to turn something on. Weather's bad here too. Yeah. Well, I mean, subjective, but we did get around here. We got like 5 inches up further north. They got quite a bit more, but we did have a snow day. Went out with the snowblower today, and it's the first time of the year. You got a cyclone. What part of the world? I take it you're not in snow country right now. India. Oh, all right. Bad everywhere. I'm in the northeast U.S. Hmm. Jeez. Uh, how's admin of code treating you, Radish? What is this exactly? Yeah, I had to mute myself for that one. I might be muting myself a lot tonight. Hey, Lil Freezy, good to see you here. Is that so? Well, if I need to die, I'll go ostrich. In fact, let me just get more water right now. Be right back. Oh boy. Okay. I'm not sure what's going on in this. Is this code? Um, what's it testing? This is a weird thing to share, I think. Make an attempt to optimize filters. They're talking about this. Lazy val matches. Um, they're trying to optimize somehow, but I don't know what they're optimizing. So I'll leave it at that. Wait, did they go with a one-liner here? Let's expand this a bit. Oh, okay, here we go. Um, so what are we doing here? We get matched. This is the number. Okay, so we're just counting through. I mean, it's set C small. You probably don't really need a set intersection. And in fact, this might even be faster. I'm never really sure with set. Like, there are things that are theoretically faster, but it depends on the size because of all the overhead of the set itself. Hmm. The Valley of the Winter. Okay, this is the score from part one. And processing. Okay. Um, this is a recursive function, and there's an accumulation of the cards. I think I would definitely do that in a map, but this is an immutable approach, which I've always found for things like a map that you continue to pass on. I've just started going mutable with it. It's easier to write. Hmm. Hmm. Oh boy, I have some redemption to do from these last two streams. Last night, I got on, and my editor was bugging out like crazy, and I figured some stuff out. It turns out one of my plugins was dropping files into source control directories rather than into the hidden directories that normally do. So it ended up continuing to analyze that. But I finally figured that out earlier today. So VS Code is happy. In fact, this problem is not. I don't think there's really much to say about it. I think people solved it, and they're talking more. I think about older problems even. Um, but one other thing I did today. So if you might have seen on a past stream, I was working on a little library. How often do I reflect on the code you write in your job or in your projects? Oh, all the time. Oh yeah, easily. In fact, I could spend too much time doing that. Mhm. Yeah, it's tempting to just go through and change things up, make it a little nicer, make it a little cleaner. Oh, PhD just rated with 143 right now, right before adding the code. Well, thanks, welcome. But why are you rating now? Why aren't you doing admin of code? Are you not showing? You're probably so fast you'll be on the leaderboard, which precludes you from streaming admin of code. Oh, thanks for all the follows. You've caught me on a day with a terrible cough, so I might mute myself to cough my guts out every now and then. Well, what a rate. Eric Wastel comes in. Yes, I hope I'm ready for day 5. I need some redemption. The last 2 days, I was just I sat down and I was not ready, not warmed up. I had some crazy brain farts. But you know, those are videos I can review and maybe look at what happens to your decision making when you're under pressure, when you know when things in front of you are breaking down, your editor's not working, and how do you prepare for that? So if I were trying to run things right now and all sorts of things are going crazy, how do I make sure my decision making process is still okay? It's something to think about, and I'll do that at some point. Do I like Kotlin? Yes, yeah, I like Kotlin. I much prefer Scala. I feel like there are a lot of things. Kotlin is the better Java. It has a lot better I don't know interop with Java, and Scala's kind of abandoned that and has gone off and done its own thing. But its own thing is more interesting. There's a lot. You have a lot looser reins. Post session review when you're done with AOC. I usually do a bit of a post session review. A review refactor. Maybe I pull up other people's code if they're done too. And sometimes I go back to working on. So like here's library code for things I might use. Um, Points, areas, intervals. Uh, excuse me. All this code, by the way, is on GitHub. Right there in that link. And if you want to join my leaderboard and push me down even further, then here is the code to join. That shirt looks expensive. Well, it's not that expensive, but the reflections are not the way the light shines in it does make it look good, doesn't it? It's one of my favorite shirts. The Scala community, oh, the Scala community is great. It's such, I don't know. So like Scala is enough at the intersection of like academia and industry that a lot of interesting things are happening. So the ecosystem is always moving along, and the community is very involved and passionate about it. Um, and very open. Like all open source libraries I do, I've met the maintainers at conferences and or like online wherever. It's really nice to like know who wrote your code. So I recommend the Scala community. They're also on Discord. Um, I also started this. Let's look at some of these tests. Okay, these tests here can give you. Let me put myself behind. Can give you some idea of what these classes do. Point, of course, as north, south, east, west. I'm trying to avoid stuff like mixing up y and x, all this stuff, all these little mistakes you can do in the moment. It's if it's already here in the library, then you won't make those mistakes. Turning points clockwise, and just all these functions on areas. Get the border, indices, yada yada. Yeah, I love I love maintainers. They do good work. Okay, I better start getting ready. So I'm just gonna copy paste this as day 5. Yeah, honestly, Scala is very easy to pick up. It has a reputation for being like a complex language. I know its definition, its spec is actually very small. It's just a very flexible language. Um, and there's some reason for that reputation. Like some people go like way off the deep end for it. But I honestly think it's a great learning language, and it's been used for that. And I would personally use this for teaching someone a program because it's simple and it gives you a lot of help. It's like Python with types in one sense. You could treat it just like that. Um, let's go back to the calendar. And so, hi, do you use Scala at work? Spark is still on 2x. Yeah, Spark. Spark is always behind. Oh my god, this cough! I tell you. That's my alarm, so I don't keep coding before even the code start. I've done that before. I I did that last night. I was like, I don't know, I was like 30 seconds late to the problem. So I have alarms now. Okay, let's remove some of this stuff. Let's just change the text. Day 5. And let me check. We are about to download day 5 as soon as it drops. 38 seconds. Java adds var, which is an infer type. Infer types are nice. Scala has infer types to the max. Like you can derive, you can use an inference mechanism to derive types that you wouldn't know how to type out yourself. Um, I don't know, that's not the best way to explain it, but basically, basically it can auto-generate code for you by solving logic problems. Okay, someday I'll have a better answer for why inferred types in Scala are and derivations extra good. But day 5 has dropped, so let's read it. I'm just gonna go here. What is the lowest number, location number that corresponds to any of the initial seed numbers? So we have a bunch of seed numbers. We want the lowest location number. Oh, okay. We have a bunch of maps here. Uh-huh. And they're all full numbers. We can parse that. And then we have a bunch of seeds. Okay. These are big. Probably I'll have to use longs. I can't tell how many digits that is. Okay, let's read a problem. So, I've done all the questions. Yes, yeah. The last 2 years is when I started doing it, and I solved everyone before the next one came out. We have to, so we are on an island. There's a garden, a farm. We run out of sand to filter it with. Okay. We barely have time to agree to this quest. We have a food production problem. The almanac is my puzzle input. Lists all the seeds that need to be planted. Also lists what type of soil to use with each kind of seed. Okay, how do we read this map? What type of fertilizer to use with each kind of soil? Soil to fertilizer. Oh, okay. Fertilizer to water. What kind of water to use with the type of fertilizer? We have different kinds of water. We're fancy here. Hmm. Hmm. I hope my noise cancellation is taking out those coughs. Mm. Okay, every type of is identified with a number, but the numbers are reused by category. So are these the numbers here to the left, and what do these other numbers mean? Which seeds need to be planted? Okay, these seeds need to be planted. And where else is 79 here? 79 doesn't even show up in here. So I guess it's not an ID. The rest of the almanac maps which describe how to convert numbers from a source category into numbers in the destination category. How to convert a seed number to a soil number. Okay. Rather than list every source number and its corresponding the map ranges of numbers. Okay, we can do ranges. That can be converted. Each line within the map contains 3 numbers: a destination, range start, the source range start, and the range length. Oh, there's no range end. Source range start and the range length. Oh, okay, range length for both of them, I suppose. Yeah. Okay, so this is saying like 49 through 49 plus 8 plus. Okay. Um, okay, how am I going to represent this? So we're gonna have pairs of ranges that I suppose we could even zip together or something. But we have pairs of ranges, and for each of these, water to light. So we have some sort of maybe we parse that to a map object, or maybe we just name them. Um, okay, so consider again this saying 50 and 98. So that means 50 goes to 98 and so forth. So 51 would go to 99. I think I get it. Contains two values. Any sources that aren't mapped correspond to the same destination number. Wait, what? Oh, okay, so 10. We'll just go straight to 10. Ah, all right. So each of these essentially describe functions. Or yeah, map. A map is a function, etc. Okay, so we'll need some sort of convert. Okay, and then what do we do here? The lowest location numbers. So the last map is location, and we want the lowest location number for each of the initial seeds. So I spent 4 minutes reading this. I think I understand it. Let's see how long it actually takes to solve it. Okay. So we have our input. And I think what we're gonna do, we're just gonna take we could split these on empty lines, but I find it's usually better. Okay, so the first line is special. So we're gonna get our lines iterator. Val seeds. So let's do this. Val s. We're gonna match on this seeds. Star seed string input.next. It knows exactly what I want. And there's no comment here. To int. I think we need to do too long. We're just gonna do too long. Okay. It has a problem with that, but we can ignore it. Okay, so we have a list of longs. Great. And then val seed to soil. I'm just gonna call it seed soil. So we're gonna do like input dot take while tag while non-empty, and then lines, and we're gonna map. So case. So we're gonna match. So there. What are these things called? There's a destination range start, dest start. In fact, let's just call it ABC. And we'll give them actual names. We convert them to longs. BC. So we have, I think well, yeah, let's do this. So a dot to int val source start p dot to int, great, val range length. And then, so we have the dest range. So dest start to say until dest start plus, we'll just call this length. In fact, you know what? Let's just sort in all of these. Dest until dest plus length. And then we're going to tuple this whole thing with source until source plus length. But wait, we need an S here for reverse interpolator. Okay, and let's just do this as a list for now. We might want to give these more structure. And you know what? This might need to be a function. But first, let's so what does this start with? Okay, this starts with the seed to soil map. So we can make this a function, def abstract map. list of range. And it's just going to be this function here. That way, if we decide we want to do more parsing of some sort, extract some more ranges. I'm just gonna let's know this is mutable here. Wait, lines. What's the issue here? Found a list of range. Oh, you have a tuple of ranges. Okay. And let's start, before we extract all the other ranges, I'm going to start by taking the seeds and trying to convert them. So each seed is potentially converted into a range, or it's converted into just one. So I think at some point, so what happens if maybe not a seed, but like a water has nothing corresponding in the next, then does it just correspond to the same number? Page number, etc. Where is it? The lowest location number that corresponds to any of the initial seeds. Yeah. Any sources aren't correspond. Okay. Corresponds to the same destination number. Maybe I should do this as a big map. How many values do we have? We don't have that many values. Yeah, we're doing this as a map. um, right, so we start with this one, for example, and we get a range of values. And then we take that range of values. So I think we should convert this to a range of values at first. So this is just this thing to itself. And then we take this range of values and we plug it into here. And and then for it might partially overlap with the range, which means some of them just go to themselves. So the map does get bigger. Some of them just go to themselves. Some of them get mapped. Maybe I should keep a large map of potential values, and then we just keep mapping on the values of the map and keep the keys the same. Okay. So we'll just call this our start map. So this is a map from long to a set of long. And I suppose it starts with empty. Then in that we take all the values in the set that it goes to, or not with empty. It starts with itself. So we're going to do seeds.map. So just a set of itself to map. Def apply ranges. So we have we're going to call this, well, okay, we'll just call it a map. We had this map of long, so long, and we have ranges. I don't know if that's right, and and I don't want it either way. It's probably wrong. Okay, and we get another map. Yeah, perfect. Okay, so for each value, so we're going to take map.map. That's why I didn't want to name it map. What's the left side typically called? Let's see. We have a source category and a destination category. So let's do that. So case, um, we have a source, and then we have a list of destinations. In fact, you know what? We don't need to do anything with the source. We're just taking the destinations. So we're going to take map dot map values, and these are just destinations. And then we look in this list for a left range that contains that. Um, so we find okay, we find one such that the first element contains. In fact, we're gonna call. Nah, we'll just do this. Contains what are, I guess, anything from heads. Oh, I suppose we do this for each of these destinations. Okay, so we're gonna take des.map, and I'm wondering if this shouldn't be. And range dot find case. Yeah, I like those names. Except it's backwards. Don't need a case here. So we find such that source range and their destination, prior destination. I guess this is kind of like the current location. Or it is a possible destination right now. Okay. And when we do find that, the thing is, we're probably going to need to optimize ranges. I'm not sure if we can just have a map. I'm gonna risk it. It didn't look that large. It can't grow that much, can it? Like, what's the most this can grow? So we have so and so many values, like 20 values. Oh, some of these ranges could be. Oh boy, look at that! Look at those range sizes. I should have looked at this to start because I'm not gonna have a map with that many values. Okay, we're gonna start by just working on the ranges. So how do we combine a range? So let's say these destinations are themselves a range. We can't have that be a set. It'll be way too large. So hmm, I think we don't even have longs here, um, right? What's our end goal? Our end goal to any of the initial seed numbers. So we don't even need to keep track of the initial seed numbers. So the starts are just going to be the ranges. So list of range, and this is going to be S to S. Hmm. Um, this is this has to be a numeric range. So let's just import that, um, or let's just say numeric range. Actually, we're gonna import range as just normal range. Okay. Um, numeric range does not have the same kind as its bound. Wait, it's bound here. I shouldn't have to deal with that. Okay, let's just do this. What do we get? This here. Yeah, sure. Okay, so we have our ranges. So we have a range. We're given two sets of ranges. So let's just say this is current. That's a list of range. Oh, you know what? You know what it is? Range here. I think that's a type. Got numeric range. Because it could be any kind of thing that's not an int. Let's do this. Um, so we're gonna de-import the range and type range equals numeric range of long. Okay, that's what we're doing. Okay, now this can be a list of ranges. I see. Um, ugh, I should know this stuff in advance before using it. And I'm going to put this up higher, like right at the top here. Now here, when we want these ranges, it's a reminder that we want actually too long. Okay, so here map does not exist anymore. Current list of ranges to ranges. And we're gonna have to think about what we do in the case that, that some overlap is missing. Okay, so for each of these ranges, we turn it into more more ranges of some sort. I guess, you know what? I guess these ranges get split, right? Let's say I'll probably have a smaller function, a helper function that just works with a single range. Def by range. So we have current, we have a range. And then let's say we find some ranges that are applicable. Or, let's say we find a pair of ranges that are applicable. Um, so we have two ranges in here, range. I'm just gonna comment this out for now because it doesn't compile. And we should come up with like a list of ranges. Yeah. Okay. So we know this range overlaps with that range. So we're just gonna take the intersection. Oh, this is where my interval type comes in. So I had where is it? It's in here. Class interval. So this is a nicer range type. Problem is, it only works on int. I need to fix that. But it lets you do things like take intersections and stuff like that. So just intersect um let's do this. So we have source dest equals map ranges. That shouldn't be tupled there, but we're working with it. And then we have current dot intersect source. And what does code like that look like? So let's say we have val this R, or we'll just call it C for current. So we have 1, 1 to 10. And val source equals 2L. Yeah, so let's say it doesn't maybe, it could be a shorter range and not overlap all that much. So let's say 8L to 12L, right? And when we take the intersection of that, intersect S, we get this vector, which is not quite what we want. So we're going to need to take val overlap. We're going to need to take the min and max of that. And actually, if these are gigantic ranges, we're not going to want that have that to be a vector. So we do want to. So I'm just going to copy some code from here on the right. The same kind of idea. Yeah. We could do a search, like a binary search for the minimum. We don't need to do binary search. This min and max less than greater than should be enough. I'm gonna think about this carefully. When you start to get to harder problems, I want to avoid moving forward without thinking about what I'm doing. Oh, some questions, by the way. Some questions take multiple hours. Yes. It's almost like the countdown for New Year's. It's countdown for Christmas, technically, but it, I don't know. It's a countdown until you don't know what to do with your life, because for a whole month, your whole life is advent of code every night at midnight. Then midnight comes up the day after Christmas, and you're like, oh, what do I do now? Do I just sleep? Who sleeps? Uh, some questions take multiple hours. This one might take me an hour. Okay, let's do this. Def intersect. We're gonna intersect two ranges. So yeah, we'll just call it left and right option range. Oh, could that be correct? We're gonna test this. So intersect CNS. Numeric range 8 to 10. And what happens if we intersect C with something that doesn't overlap at all? Let's say 11L to 100L. Okay, yeah, that's good. Okay, great. So once we have the intersection, the thing is this intersecting part, now there's a D, a dest. So let's say val D, this is always going to be the same length as S. So let's say it's 18L to 22L. So that means this 8 to 10 should become 18 to 20. And to do that, we have to drop the same amount from the left sides of both S and D. So what would we do? Val left drop. So how many we would drop from the left of the source range? I should look at this and tell myself that I don't need to panic. That's fine. I take it slow. Okay, are people done with the first part? I'm getting there. No one on my leaderboard yet, or no, this is Scala leaderboard. Yeah, so people aren't finishing. This isn't like easier than I think it is. So I can continue to take it carefully. Oh wait, what did I delete? Um, okay, so the left drop. Um, so we have the intersection. The val I equals intersect CS, and this was just some test. And this tells us how much to drop from the D range, right? Yeah. Um, and it's exactly how many pieces we drop from the C range. Um, and in this case, we didn't drop any. So in this case, it's 0. This here. So 1L to 10L. We start at 8. So we do an if here. So if S starts after C. So if S dot min is greater than C dot min, yeah, S dot min minus C dot min. Okay, so this here should be the correct value. Then what do we do with that left drop? So in this case, it should be 0. So this is going to be like a floor. We'll actually want a floor function. Oh wait, we have an else here. So if our source starts after the current, then we are dropping stuff. Otherwise, we drop nothing. And then for the right part, we just compare lengths. Val take amount. Oh yeah. Hold on. What was left drop? 7. Um, we are taking okay. So we're not dropping anything from D, but it is worth noting. Like we should still take these first 7 into account and note that they just go straight to 1 to 7. Hmm. Jones, thank you for the follow. I hope your admin of code is going well, if you are doing it. Okay, so the 7 number is still important because we're going to do like a C that take 7, right? And that's the range 1 to 7, which will just get mapped to 1 to 7. So we'll call that like the leftover, right? Val leftover. Um, and then the overlapping range, we have the overlapping range. The overlapping range needs to be converted. Uh, and what do we convert it to? So in this case, 8 to 10. Wait, where's our overlap? 8 to 10. So if nothing was dropped from the left side of this, which in this case, wait, nothing was dropped from the left side of S. So we need a new name. What as that was the original left drop I was going to do. So let's rename this. This is this is the unmatched. Yeah. The unmatched bits on the left, which in this case would be there'd be 7. So C, and then we take 7. We'll probably need to get better names here. So val source dropped. Well, in this case, it should be 0. And it's 0 because s.min is greater than c.min. So if s.min is greater than c.min, then 0. Else the source was to the left, and in that case, you take c.min minus s.min. In this case, yeah, we should get 0. We have a problem. Not found left drop. Yes, that doesn't exist anymore. Okay, so this is a leftover. And then we have converted. So we take the source dropped. This is actually just stuff that's dropped on the left of the source. I mean, either way, we take like the overlap length, right? Um, either overlaps. So the source is actually either overlap on the left side of them or the right side of them. And that's how we choose whether. Hmm? This probably will all end up going in one big if else because it's going to share some logic. Because again, we're doing an if. So if s.min is greater than c.min. Okay, so in this case, let's call this dest leftover. Wait, is that oh no, this is actually the leftover. So number of bits converted, or actually just the range converted. So we're gonna take our goal right now is to take this intersect. So we take the intersect dot size. So if a source starts after the min, then we just take that much from dest. D dot take I. Else, otherwise we're on the right. So we're going to do D dot take from the right I. Okay. So converted in this case. Whoops. It has a problem with this. Oh. Yeah, we can convert this to int. That's probably fine. Oh my god. Oh, this is gonna give us a take, right? We can't have. Excuse me. We can't have that. Okay, we're gonna drop instead. So we're gonna drop from the left based on I. Dot drop. And it'll be like D dot size minus I dot to int. Yeah, exactly. Um, oh, right. So this would be like an I dot get. I mean, later down, I'll do like a flat map or something over that because it might actually be empty and we have to handle that. Value to int is not a member of range. Wait, what is I? I is an optional range. Oh, wait. I get that size, that to int. Okay, so in this case, converted is 18 to 20. That's what we want. Let's put all of this stuff. I don't know if I'll refactor it. I won't refactor it. I'm just gonna put this into this function here. Um, we have an intersects function. That's great. So we're gonna copy most of this over. We can refactor this later. Just hoping we don't have to like debug it right now. So I is the intersection, and S and D are actually now source and dest. I'm gonna do a trick here. We're just gonna rename that to S and D, and then just for legibility, we can rename a symbol source. Oh, I only changed that one. I have to save it first. Okay, we have some unused things. Unused local definition overlapped. Um. Oh yes. So we don't need that. The I is fine. Okay, we are not taking into account this unmatched left. And we'll need to do that. Source dropped. Was I really not using that up above? It seemed like I needed it at the time. Oh yeah, leftover dot take unmatched left. Um, that to int. There we go. Okay, and source dropped. So this was a 0. We sort of implicitly used a 0 somewhere in here. The leftovers. So the leftovers will be part of our list of ranges. So we can do list leftover and something else. We're gonna get converted. Leftover is a range, yes? Yeah. Found value. Oh, wait, it's capitalization problem. There we go. And source dropped, we are not yet using, but you know, we're at a place where we can test this function. So def apply range. So we have 1L to 10L, and this is S. I'm just gonna rename these here. S range, range, and we're renaming this to C. The 1L to 10L. Yeah. And then we need to test like an overlap to the right, to the left. So we're going to test that. We're going to test, still needs to be, what is this, 18, 19, 20, 21, 22 of length 5. So we're going to do like negative 2L, negative 2, negative 1, and just to 2L. Okay, so we have an issue here. Identifier expected. Let's put our apply range function. This it seems fine. Oh wait, it's not a def. We're just testing it. Okay, here we go. So we have the range 1 to 7 and 18 through 20. And in this case here, we have a problem. So we're only handling the left side. I'm sure, like looking at back at this, when I'm refactoring this later on, this is gonna turn into like 5 lines of code. I know it's a lot simpler. I'm just not wrapping my head around it just quite yet. Okay, the source dropped. We are not yet using. So suppose here, let's just walk through this if S range was overlapping to the left. Right, and in this case, we have a source dropped of like 2. So when we are converting, we are converting, and this leftover will depend will depend a little bit on this too. So this is another if else. So if s dot min is greater than c dot min, then I think we want this current code. Yeah. Otherwise, we drop source dropped. Otherwise, take s dot drop source drop dot to int. Okay. We are now using everything. I don't know. That might be it. Let's take a look at it. So for the second one, we get the range 1 to 2. That's not quite right, but the 21 through 22 should be correct. No. What we're expecting. What are we expecting? So for this one, we are still getting the right answer. And then let's just do like an A equals whatever this is supposed to be equal. So let's have a couple ranges. Yeah, that should be true. That should be true. 1 to 7 and 18 through 20. Did this not compare? I don't know. We'll do like same elements as that list. Okay, you know what? Printing it is good enough. Okay, so here, since we're overlapping 2 on the left, we should get 3 to 10. So 3 to 10, and we get the part that overlaps is 1 to 2, and that gets converted to 18 and 19. Okay. So here, leftover. S dot drop. Oh wait, this is C dot drop. C dot drop. There we go. So let's take a look at that again. Here we have 4 to 10. That's too many, but it is the right idea. So it needs to be 3 to 10. Is this just an off by 1? C dot min minus S dot min. Okay, let's think about this. So let's say our C is 1 to 10. Oh, this is telling me like how many I dropped from the source. Where else do I use source dropped? That's the only place. So in this case, source dropped should be should be 3, right? Because we're dropping 3 from source. But it might even not even be necessary. Okay, so that's fine. That's getting the right value. Um, so in the case that source is to the left of C, we just drop whatever overlaps. So the amount of the overlap, which would be s dot max, s dot max minus c dot min. Again, this is assuming there's an overlap. In fact, this intersect here, we're gonna do this. We're gonna fold and add a default case here. And the default case is going to be if there's no overlap at all, just a list of the same thing, list of C. Otherwise, then we have our I. And now we don't have to do any dot gets. Now we don't have to think about that case where they don't overlap. Take these dot gets out. And at this point, I'm starting to think about like putting these all into one big if else branch because it might actually be easier to think about it that way. Yeah. Okay, I have a slight bitrate issue. Let me just take a look at that. I'm not sure if the stream still looks good. Oh no, the stream is crapping out a little. Okay, I think we're just lagging behind up, and we're fine. Okay, this is the amount dropped from the source. So the leftover here, so we do like a C dot drop. S dot max minus C dot min. Let's see, let's just see if that's correct. Up to int, up to int. Or you know what? Hold on, we're gonna do the conversion afterwards because those could be longs. This is a time when I'm jealous of Python having to think about ints and longs. Okay, so in this case, we get 2 to 10. So this is not the one I expected it might be. That's why I checked. Okay, 3 to 10. And the right side should be 18 and 19. Okay, so converted. This first converted was right. E dot drop. I think this is a source dropped, the number dropped from the source. Okay, so that works. I'm absolutely certain it can be. Oh, interesting. Oh, 21 and 22. That is actually the correct answer. So my comment here is wrong. 21, 22. Okay, great. So we have the hard part of the problem then. From here, we can just straight up solve this. Um, so let's go back here. So we have so we look through these ranges for something that overlaps. So current dot map, and we have a C, and then we take ranges dot filter. Oh, what if multiple ranges? and multiple ranges overlap with it. That would be annoying. I mean, let's look at some of these ranges, right? These like overlap with each other. I don't know what to do there. Hmm. Well, I mean, we're just gonna do it for each. That would explode. That would explode in size very quickly. We wouldn't want that. So maybe we assume for a second that that isn't the case. Let's look at the test data. 0 to 15. Wait. No. It's not 0 to 15. 0 to 37. 37 to. Oh, okay. So in this case, that's fine. I'm just gonna do a find. So, and leave it to do here. There's smarter search. Um, maybe like a binary search of some sort. So ranges.find such that um, uh, so we have a left side. Let's do this case SD. We don't need a case. Okay, SD. Perfect. This is perfect. So s dot contains c dot min or s dot contains c dot max. Okay, great. And if there's no overlap, so this our apply range method handled missing overlaps. We're never actually gonna send that to it, so we're gonna overlap that fold. And in this case, we're gonna turn it into single range. So just a list of C. Otherwise, we apply range. Apply range C. We'll just overlap, end up returning again an S and a D. Yes, that should be fine. Great. And now this is actually gonna be a flat map. And the end result here will be a new list of ranges. Yeah, great. List range. And I guess I'm happy with a list of a tuple of ranges. That should maybe be like a tuple of lists of ranges. But I think it's probably fine. It works either way, so I won't change it. So this turns into a flat map. And now we can do a test on some test data. I'm not going to try just on the input today. That would be too ballsy. So day 04, no, 05, 2023. Let's save this as test. And now let's go copy this in and test that out. We can test it step by step. Okay. So we have a starting list of ranges all the way up here. Okay. And we had a way of getting ranges. What is it? Extract ranges. Okay. So apply ranges to we have a start list of ranges and extract ranges. So start. Let's just take a look at what start is. Okay. Just remind ourselves. Oh, oh, hold on, hold on. We want to use our test. Oh, okay, here we go. Yeah, so we have a range for each of those. And apply ranges, start, extract ranges. What's the problem here? Required. Wait. We had a list of range and we required just a range. Oh, apply ranges. Okay. Okay, so we get 79 to 79. Great. It doesn't go anywhere. 14 to 14, 55 to 50. Wait. No, no, no. Some of these surely. Okay, so our first range covers 50 until 52. And our second range covers 52 until 100. Let's look at what extract ranges gets us then. Oh wait, did I test out extract ranges earlier? This is this immutable function, so we can't just be. Oh no. Okay, let's look at what we get from extract ranges. And we actually end up with an empty list. Interesting, because I thought we had no issue with that earlier. Val seeds. Sure. Let's just look at the next line. Line's not next. Whoops. Or input dot next. Okay, yeah, let's just get rid of that empty string. That's fine. And now when we call extract ranges, okay, now we're getting an error. Oh, yes, we have to drop seed to soil. In fact, we can do this. Extract ranges or input.next. And this could serve as documentation while we're going. Seed to soil map. Okay. And then now, when we do the extract ranges down here, it should use that seed to soil map. Okay. 55 to 55. Oh, did I? Oh my god. I think I really over-engineered this problem. Oh my god, I'm just realizing it now. What does 55 get converted into? So 55 falls into that range. It should become 2 larger. It should become 57. Just 57. It's not a range. It doesn't become a range. It just becomes another int. Oh my god, I was so over-engineered this problem. Ah. Oh no, why didn't I realize? Okay, okay. This problem is easier than what I solved. But I mean, my solution I think is general enough. It should work with this. Right, a seed only goes straight to. Oh, okay, okay. You see this, right? Y'all see what happened here? Okay, so we just look at. Okay, so next we have current, which is just gonna be a list of long, and then source Yeah, source is going to be a list of range. So basically here, an hour in, we are resolving the problem in a much easier way. Best list of range. And then we should get a new list of long. We're just converting everything in that's long. Okay. The current.map. There's always going to be four. Oh, wait. Hold on. We did want the ranges, right? Because 79, 55 can go into any of those, right? And any of those could get mapped into any kind of fertilizer. So there's a huge range of fertilizers. Okay, no. I did not misread the problem. I can I can do it this way. Whew. Um, okay, great. We do still want ranges. So when we apply ranges, why are we still getting 79 to 70, 79 to 79? 79 should have been caught. Um, so we have 52 to 100 and 50 to 98. So let's just apply range here. So we have 79 to 79. I think we did write our apply ranges function a little bit wrong. So these are all of our current things. Could be. Am I misunderstanding the problem a little bit? I think I might be misunderstanding the problem. Let's just read over this again. Contains a list of convert from a source category to a destination category. Okay, so what should 79 actually look like? Oh, okay. I did misread the problem. 79 corresponds to 81. It doesn't correspond to like a full range of numbers. 14 corresponds to 14. 55. I did over-engineer it. Okay, so given our C, we take sources dot find s dot contains C. Yep, exactly. I'm not gonna call it overlap though. Um, and if it's found in there, we just do the conversion. So that map. Um, and these sources and dest ranges are always going to be kind of one-to-one in size, right? So I don't think I need to turn them into ranges. We just add the size. C plus um, okay. Um, plus the size of the range or the difference in the difference. Dot min minus this dot min. I think there's a +1 in there. So if it's 2 greater, no, that's it. And we can actually make this a fold because we have a default. The default being just C. Okay. Yep. S.min. Or actually source.min is fine. Wait. Oh, we need the thing it's paired with. So ranges. So these ranges are paired, so we should have a tuple. Um, a list of tuple ranges. Yeah. Right, let's put this up. Let's put this up top. Ranges dot find the left one contains C, and then we have an S and a D. Okay. So now we just do the next apply it to so we have what art? No, we just have seeds. So we have seed and extract ranges for these. Okay, 81, 14, 57, 13. Oh my god, this problem is so much easier than I thought. And then of course we have an input that next. Yeah. Okay. Great. Um, so we can like put this in an iterate function until it's empty. There are just a few of them, so I want to see these strings. So I will just I'll just copy paste a few times until we get final light to temperature, temperature to humidity to location, val locations, and then val ans1 equals locations dot min. Oh my god, this problem is so easy. How long did this take me? This took me 5 minutes, right? I noticed this at 11:04 or something. This problem took me 5 minutes. I solved the wrong problem first. Okay, I mean, it's not, oh wait, of course. Well, okay, it's not quite solved yet. We're expecting a 35 for the test data. Um, so after 1, we have 81, 14, 57, 13. And what's this location? 82. The other categories will find its location number. Oh wait, this tells us what happens to seed 79. So it becomes 81, and then it stays 81. Why do we have negative ones in here? Okay, let's just think through one step of this manually. So we've done this 81 through 41, and then we do the soil to fertilizer map. So where's the soil to fertilizer map? Soil fertilizer. So we have 0 until 37. Just to check, was I doing that as untils when I was parsing them? Because that should be until and not to, I think. Yeah, we were doing that. Okay, so we use the soil to fertilizer map. And 79 just goes to itself. Or 81 just goes to itself, right? Yeah, 81's not the soil to fertilizer map because it's 39 plus 15. Okay. Um, let's just print these when there is an overlap. Yeah, sure. Found CNS. Okay, so after this, when we're using this soil fertilizer map, found 14 in 0 until 37, found 13 in 0 until 37. Okay, and 0 until 37 gets turned into 15 until whatever. So it becomes plus 15. Found 13 and 14 though. There, yeah, 13 and 14. We should add 15 to each of those. So there should be 29 and 28. And meanwhile, the other ones that were not found should just stay the same, right? So we just fold to C. Oh, seeds. We're applying them to the same seeds. Okay. This is why I should have used an iterator in the first place. So how many maps are there? One, two. Okay, we're gonna do this. Um, so far, current equals seeds or equals start. We don't need this. Okay, so each time you do this, var current equals whatever. Hmm. Oh no, we don't need to redefine them. We just do current equals. I don't know how to use vars. I never use them. Okay, now let's take a look at this. And then like I guess we'd want to do some sort of like print line current. Um, can you believe I'm doing this here? Okay, so now we can see how it's moving. Um, so A114, yes, that's good. So we found, so we have 14 and 13. We found 14 in the range, and we found 13 in the range. Oh wait, this still shouldn't be seeds. So we're gonna do a little find and replace seeds with current. Okay, great. And now this is what we're initially trying to fix. So yeah, we have 8114, whatever. And we pass it through this map. We found 14 and we found 13. And we reassign current. So 81 passes through. Great. So that's good. 57 passes through. So now just this part is wrong. So I think we just need to reverse this. D.min minus S.min. So it should be adding 15, 29, 28. That's perfect. That's perfect. So for part one, the answer, or for the test, the answer is 31. 35. Okay, there is a slight mistake in there somewhere. Probably like an off by one on some range. C13. So 13 is always going to be on the right side. C13 gets soil 13, gets fertilizer 52. Built a fertilizer map. Um, We use a soil to fertilizer map. 13, a seed soil map. So we start with C13, get soil 13, and we should get fertilizer 52. The fertilizer was found in range 0 until 37, or rather 13 was found in range 0 until 37 in the soil to fertilizer map, right? So that's this first range. And we do add 15, right? Because any from 0 to 13 to 37 gets mapped to 15 to 37 plus 15. Oh, hold on. We don't we don't just we don't just add 15. We add into the index there. So yeah, let's think about this here. So adding that much is part of it, but also we need like the index into. So we're gonna do like d.min plus, the answer is gonna start with d.min. d.min plus however much of s we skipped, 3 minus s.min. Exactly. Okay. So now this 13 turned into something else. So we found 14, we found 13 in numeric range. Going to test until 52. So it should be like the 13th value. Oh, we do add 15, right? Am I crazy here? So if 0 to 37 matches to 15 until 52, then a 13 should be 15 plus 13. Um, let's undo that a little bit. So we'll uncomment that. Should it be a plus? Yeah, it always just gets shifted over 15, right? So it should be plus 15. Um, why? So I still don't understand the problem then. Why does 13 go to what it's supposed to go to? So here we had C13, the very last one. It's the soil 13 and goes to fertilizer 52. Why is it going to fertilizer 52? We have 0 to 15, or 0 to 37, 15 or whatever. And 13 goes to 52. How? Okay, let's read this. I've clearly misunderstood something. I convert numbers from source category into numbers of destination category. Sections that starts with a seed to soil map describes how to convert a seed number to a soil number. The destination. Convert a seed number. Yeah. And what is that relative? Rather than list every source number and its corresponding destination one by one, the map lists entire ranges. Each line starts with a map. Each line within a map contains three numbers: a destination range start, a source range start. Oh, it's a destination first. The source range start and the range length. I think I'm going to change extract ranges just to give me those, because all we have to do is add, well, no, not the range length. We still add the difference. So I won't change anything there. Um, Destination range start. So I've been misinterpreting this. This is, for example, here, this is a destination range start. The source range start here is 0. And the length. So 0 to 15 goes to 39 to whatever. Okay. Let's extract the ranges. Dest until I had done it right the first way. Oh, and you know what? Do you remember earlier? If you were watching earlier, autocomplete was telling me to do dest first and then source later. And I kept fighting against it. I kept saying, no, why are you doing that? I kept putting the source first and then the destination later. Um, and you know what? Autocomplete was right. Okay, I'm gonna delete a bunch of this. You know what? I'm just gonna save this because day 5, what was this? This is my wrong start. Wrong start. Okay. Let me go back to day 5 and we're gonna delete a bunch of this. Oh my god, we wrote so much code we didn't need. So there's a start. This intersects function, this apply ranges function. I don't know what I was thinking. I was thinking Topaz was crazy throwing us such a hard problem today. We don't even need this. We have our seeds. Yeah. uh, and here we simply check if 2 contains. You know what? It was auto-completing that to 2 as well. So this is D, and then this is S. Okay, 13 becomes 52, yada yada. We could get 35. We finally solved it. Okay. We finally solved it. I'm gonna redeem myself from the delta. Watch me here. Okay, so we have 806.029, 806.029.445. You know what? That doesn't need to be a long. At least right there. I think I see larger numbers here. Okay, continue part 2. Redemption time. Everyone will starve if you only plant such a small number of seeds. It looks like the seed line actually describes a range of seed numbers. Oh. Divide an initial seed line come in pairs. Within each pair, the first value is a start with a range in the second. Okay, this is sort of like the problem I solved earlier, except now we look at the input, and what do we have? We have, wait, this is a crazy range. This goes negative, right? No. Okay, but this is a crazy range. So now we're back to solving a little bit of a harder problem. I wonder if there's overlap between this and my first approach altogether. Okay. The first value is the start, the second is the length of the range. Oh, okay, length of the range. I'm just gonna say this is part one. Day five, one, because we did it in such a mutable way. Like this is not going to be not going to be preservable. Okay, so seeds. Seeds is actually different. Next, instead of a list of long, we have a list of ranges. Ah, remember when we were looking at a list of ranges earlier? There's something. There might be something in there I could copy paste. Um, so seeds. That's going to be a list of range. And now nums is that, and then nums dot root to, in that case, a to b. Is it an inclusive range? This line spreads two ranges of seed numbers to be planted in the garden. 39 plus 14. Okay. A to A plus B. A plus B. It contains 14 values. Oh, that should be until B. Until A plus B, not two lists. Look at these. That have other issues with me. Um, Seeds. Where are they? So these are grouped into a two. We take the two elements and turn it into a range. And put the two list call up here. And why are we not showing anything right now? For one, I can comment out all this stuff. Not really using. And this is actually really easy to do. We can do like iterator dot iterate. Yeah. So we start with honestly we start with seeds and we apply next. It knows how to complete that. And then extract ranges. We don't just extract ranges because we're gonna do some print lining. So we're gonna call that current. Um, find the current one, and then put that next, and we're gonna print line that as well. That we see what map we're using. And we're gonna call this what just iterations. It's sure. And then it's that take. We can do like a two list dot last. So we take how many of these are there? Fact ranges. So 1, 2, 3, 4, 5, 6, 7. Okay, so there are seven of these. So we take 7.2 list dot last min. Okay, that is our ands too. And next now takes a list of ranges. So now We need to find one. So we have a D and S. So B dot contains C dot max. And we might have to do like those overlap ranges we were doing earlier in our first attempt. Yeah, let's read this problem further. I'm getting ahead of myself. Okay. The sign describes two ranges of seed numbers to be planted in the garden. Now, rather than considering four seed numbers, you need to consider a total of 27 seed numbers. Sure. The location can be obtained from seed 82, which corresponds to soil 84, fertilizer. Um, yeah, but I really need to walk through this. So 79 plus 14. Okay, we do end up doing that split ranges thing. So I'm glad I saved the old stuff instead of just nuking it. Wrong start. And I'm going to take this intersect method. And this time we are going to write it inside like a big if else. Yeah. So F, where did we have to apply a range? We get a list of ranges. This this right here. This is exactly it. So we do apply the range. Did I solve part two before? I solved part two before part one. Okay, I'm getting redemption on the delta here. We don't even need this. Okay, so what are we doing? Next function here, f next. No, not. We're doing this inside apply ranges. So we can end up with a longer list of ranges. So this is a flat map. I hate this bit about VS Code. Can't just capitalize from the middle. Okay, and let's do this thing again. So val overlap those ranges that find d.s where yeah, it's exactly this kind of code right here. Or rather source. This should be source. And we can forget about print lining for now. And then overlap. List of not c.min. It's going to be, oh, we don't want a list of long. We still want a list of ranges. Okay. So overlap that fold. So we just have the list of C in one case. Otherwise, we do apply ranges, or apply range rather. C, S, and D. Except our apply range is probably a little bit wrong. Nope, as long as apply ranges has the right parameter order. S and D. Yeah. Sharing my joy. Welcome back, Souza. Thanks for stopping by. Let me read this. I share my joy with you. After 4 days of learning programming, I launched my first 100% functional calculator. Has a 70% chance of getting the correct calculation, up to 80%. I'm sure that can actually turn into an interesting math problem thinking about your calculator. Um, D, S, and D as in the right order. Okay. So next, we are expecting. Hey, what's going on here? This whole thing is kind of wrong now. So we still apply next to current, and then we're going to do this extract ranges bit. And yeah, that's fine. We don't need to do any of this. Let's just drop 7 next. I don't even know where that came from. So ends 2. Oh, this is now part 2. I'm saving this as part 2. I hope part 1 is still in there properly. So ends it's that last, I guess. Oh wait, yeah, that takes 7. Takes 7. That to list. And then we map, take the min of each of those ranges, and then take the min of that. Okay, so there's some maybe small little issues. Let's just run this on the test input. And okay, let's just look at what the problems are. A5 part 2 might not be exhaustive, sure. And use, what is this? Why is it importing that? Okay. What else? Um, that's weird. I'm getting weird errors here. Unused local definition, sure. Those might be bugs. Am I getting values now? Okay. So ends 2 in this case. Numeric range. This is a list. What is its? Iterator of lists of numeric ranges. So we take that very last list. List dot last. Okay, so let's just name that val final ranges. Val ends 2 equals final ranges. Map min min. Or rather we can say min by, or yeah, that's fine. 51. And the lowest location number is 41. Okay, so let's look at our debug. That happens in here. So this is our original 79 to 93, 55 until 8. And we take the sea to soil map. We still have 79 to 93. I don't believe that. Now, in the above example list, okay, so what should it become? 79, 14 gets applied to these ranges. Oh, you know what? Different parts of the number could overlap with different ranges, couldn't it? Mm, yes. Okay, so let's think about that. And let's also do a little test. So apply a range. We do have to do this with a list of ranges. So we gotta split a range. So you gotta be able to find overlaps, right? So there's something like 79 to 14. Oh wait, no, 79. What is this to 93? Um, 93. And how many different ranges does it overlap with? So there's 52. This is a destination. This is the start. So 50 plus 48. So applying 50 to hmm, 50 to 98, which goes to well, we just add 2. If we just add the difference here. So that whole thing would just become, you know, was 81 to 95, right? And the other range, 55, adding 13. We're just gonna keep going with that first range, so 79 to 14. What happens with the next one? I think at this point maybe it gets split up. Because it's 89 to 95. So it gets preserved. We still have 89 to 95. Um, Starting positions, let them apply either. Okay, great. In the water to light map, we have um, starting at 18, starting at 25, going up 70. There we go. So this goes all the way to 95. This ends up doing the whole thing. Hey, Midnight Simon, you finished. You finished. Welcome. Welcome. Thank you for the raid. So, oh my God. I solved. I completely misunderstood the problem. Let's give you. You did not finish. Oh, okay. Well, it is a harder problem. I essentially look at what I did here when I was solving part one. Once I realized what part one was, it was a lot easier. And this is let's see, part one, 2023. Um, what have I already changed here? Because I want to take this back a little bit so you can see what happened in part one. Okay, good. I can still take stuff back in part one. Dip, 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 dip. So I was solving essentially part two instead of part one. I was starting with the ranges. I completely like misunderstood the problem, and I thought, okay, I might have a range of values and I might be like applying that to a bunch of other ranges. And I wrote all this code for it. And an hour in, once I understood the problem, I was like devastated. Like, oh my god, this is a much easier problem than I thought. And then I solved part two, and I got a little bit of redemption because this is way longer than it needs to be. I got a little redemption because this stuff turns out to be I'm using this exact method here. All of this stuff I'd written for part two, so it's a little bit of a minor relief. Why? I mean, this is a much more annoying problem. That's not true. Too hard for you. No way, no way. But part of this, like here, I already had this in library code. So this gets me creates a range of the overlap given two ranges. Um, so I do still need to like change some things. Oh, this is part two. Yeah, we don't want to be messing with that. Um, here, wrong start. Oh my God, I wrote all this code. That was I mean a lot of this is test code, like debugging as I go, or not like this is development code, like me just writing one step at a time and then putting into a function later. Um, anyway, let's close that out and let me see if I can list long. Let's go to the part where we uncomment all of this. Something happens. I like I'm gonna do this at some point. This is not gonna be a list of ranges. This my seeds is back to a list of int. What? Oh, I don't know. It's just gone. Okay, I'm just gonna close that without saving because I want to see what I had saved. Um, well, whatever. We can figure that out and show it later. Um, anyway, I think I know what to do here for part two. Um, and honestly, I think I need to rewrite the supply ranges function because we could have multiple matching source ranges, right? Um, so we're gonna do this assuming that there is an overlap and say, okay, the part of this that overlaps, what does it go to? In fact, that's actually already sort of what it does. This fold here with the default, if there is no overlap, no intersect here, it just doesn't matter. That's dead code. So in fact, I'll just make that explicit by turning this into a dot get I whatever. We just know that it's dead code for now, and we can clean up later. Okay, so it's in here then that to change things. So this is my iteration function. We start with a range. We have our end range, our ending list of ranges. So instead of just finding one overlap, we have to find all the overlaps. So this overlap is going to turn into overlaps, which is a filter. And then we also have to figure out the part of it that does not overlap with anything. Which, okay, yeah, we can do that by removing the overlaps from this range. And I actually have a method for that in my library. Oh my God, this is actually coming in handy. So in my intervals, class interval. Okay, myself behind here. So this is my class for dealing with intervals. We got the intersect, which I'm already using. Here we have a diff. You can get a list of intervals by subtracting another interval from this interval, right? So we're just going to diff repeatedly all of the intervals that do overlap. So we have dest and source ranges. Okay, and if there are no overlaps, or let me just we're just gonna put this into an if else. So if overlaps it is empty, then just list a C. Otherwise we had to think. So we have apply ranges. Uh, so overlaps dot map apply range C D S. Is that going to be in the right order? Right, it has apply range. Apply range is S and then D. Uh, my overlaps are dest and then source. This is another thing that tripped me up. My brain wants to say source and then dest. Why would you put dest first? Topaz is in here. Know that I hate that about this problem. Okay, so we're just gonna change this order. We're gonna make this D, and we're gonna make this S. Okay, high range. We're not gonna flatten that. Oh yeah, we're gonna flat map this. Okay, that's actually pretty easy. What do we call this? This is the overlap translations. Sure, we'll call it that. And then the parts that are not overlapped. Val remaining. So all the range. So we take our current. I'm gonna rename this token. So uh, he's fine. Never mind. And for each of these overlaps, so overlaps.map, we're gonna get the source ranges. What are we gonna do here? We're gonna fold. So we're starting with this of just C. So these are the ranges that we need to diff out. Starting with just the full range. And then D and S is the wrong names here. This is definitely wrong this time around. So in the fold, we first have, oh, we want to fold left. Get more help out of this. Okay, so we have our ranges. We have multiple ranges. And then we have a source. Yeah. Okay. And then we need to diff. So it's gonna look something like this. Diff. I'm not doing this with intervals, we're doing this with ranges. Oh, you know what? Yeah, so the reason I can't just use my interval class is interval here only works on ints, and I need to work on any numeric type, and I didn't write it in that way. So like I could refactor this to work with any numeric type. I should refactor it to work with any numeric type, but we'll do a little bit of homebrewing here. So we get a range. We'll make this an extension method. Extension R range. Onto another interval. No. So we're gonna call this M range and N range. So N being the one that's being diffed out of here, get a list of ranges. So here min is actually m dot min, m dot max, list dot copy. Oh, okay, copy constructor here. We have a list of ranges. So how do we translate this? So we have the same min, m dot min, to actually we don't want to write it that way. We're just gonna write m dot min to n dot min minus 1. Great. And then the other one, so this should be no, n dot max plus 1. Great, to m dot max. It knew what to do. Oh, that's excellent. Sometimes, I'm being converted on Copilot here. That autocomplete was correct. Okay, then nil, sure. If n contains, this is m dot max, m dot min, then we have a list of one element. So we have a new max and we have the same min. So m dot min to whatever this new max is. And then we have a new min to the old max to m dot max. All right. And let's test this out a little bit. So diff. So let's just start with you know 1L to 10L, and we're gonna diff out 8L to 12L. What we should remain is 1 to 7, right? Oh, it has issues with my current whatever. What is the actual issue? Current.flat map. What's the issue with this? I don't understand that. Um, well, whatever. We just comment out this whole thing for now so we can test our diff function. This. This is actually m. M. This is m dot min and m dot max. Not found next. I mean, that shouldn't stop me from running the part that does work. Okay. So 1 to 7, great. And if we do something in the middle, like say 3L to 5L, maybe we should get two ranges, 1 to 2 and 6 to 10. Great. And as a final test, let's do like negative 5L. We should get 6 to 10 and a final test. Well, let's do a couple tests. So like negative 5 to 15, that should just give us the whole thing, and something that doesn't overlap at all. So let's say 15 to 25L. So it should be empty. Oh, okay, this removes the whole thing. Great, without any issues. And this one removes nothing. Okay, I'm happy with that. Let's go back to fixing this. Uncomment all of this. And let's try to understand this compiler. This is perfectly valid syntax or flat mapping. You just write again from the start. Right? Not flat map, sure, that's legit. Yeah. Uh, okay, it knew. I don't like that code it's written. But like, I've been using the syntax the whole time. What's wrong with it? Okay, I'm gonna have to take this to. I'm gonna. You shouldn't have compiler messages like that. Woo just rated with 2 viewers. Hey, welcome, Woo. I assume you're doing admin of code. How did it go for you? Are you finished? Okay, let's just convert this syntax altogether. C is my argument. Okay, these are okay. Well, it's happy with that. That's compiling now. I don't know what issue it had before that. Probably has to do something with like this part not actually being real. So remaining, oh yes, like this whole thing. We're in the middle of writing this stuff, and I guess it just got really confused on the syntax. So the ranges that we have, exactly. We're gonna diff S out of them. And then that becomes the next set of ranges. Perfect. So now the answer is overlap translations plus remaining. Okay. Yeah. So overlap translate. Exactly. Exactly what I just said. I mean, sometimes it's like Copilot is listening to my microphone. Um, okay, so I'm happy with this. Let's test it out on something. So next, given seeds, which is a list of ranges, and just extract ranges. Oh, right. Input that next. Let's do this. Seed to soil map. So we're using a seed to soil map, and we get 79 until 93. Yes, 55 until 68. Let's look at our input. Day 05 test. Okay, so in the seed to soil map, we have 98. I hate that this is backwards. So what does this mean? 98 to 100? Yeah, 98 until 100 becomes 50 to whatever. So that doesn't match either of these. But this one, 50, and the next 48 matches things. So 55 to 13 would become translated up to 57 to plus 13, whatever there. Because we're starting at 50 plus 48 to 52 plus 48. Right? So when we do this, 55 until 68. 55 until 68. It did not change anything. Okay. So let's add some debugging into here. That's D is not used. Overlaps. Yeah. Right. We only need the source to determine if it overlaps. We have print line. Uh, overlaps. Yeah, let's do that. Or C. No, we have an extra. Okay, so this first time we did it, overlaps for 79 until 93. We have the range 52 until 100. Wait, 52 until 100? No, that's a source range. And 50 until 98. Oh, yes, yeah, okay, great. That pair of them. 79 until 93. So that should become 81 until 95. And let's see, it, it didn't, when we called next, so it didn't become anything. 79 until 93 is still in there. Okay, so overlap translations. Um, let's do a print line for each of those. So overlap translations dot for each. Let's do a few things. So let's just print some space, some indent in here. Um, let's just print the thing. This is like a new C. And I guess what I'm anticipating here is that it ends up being empty. Yeah. I could put a dash in here just so it's more legible. Translations 79 until 93. So translate it back to the same thing. If overlap that is empty. And let's just see, sure. Oh, you know what? I'd written this as a general everything. So this part right here is the overlap translations. We don't even need this if else because we sort of do that down here. Overlaps at flat map apply range. Okay, now let's see what we get. So for 79 until 93, we get these. Wait, we get two overlaps? Oh no, no. It's still just the one overlap. The dest and the source 50 until 98. Translations. Okay. This gives us a. So when we apply the range, we get a new range. Let's just try apply range. Apply range. So let's try exactly that. We had 79 to 93. And then we have the destination, which is 52. What was it here? Right here. So the destination is 52 until 100. Source is 5098. Okay. 52 till 100. And then 50 to 98. And we're getting 79 to 93. So we're going to do some debugging on that. So let's go above to apply range. Okay, so C is the current range. We do find the intersect. This doesn't even need to be a list of ranges anymore, actually, because we diff things out separately later on. So we only apply the part of the range that overlaps. So this becomes a bit easier. Yeah. So I'm just gonna rewrite this. So we find where it starts in the source range. In fact, we take the intersect. So we take the intersect of C and S, and then we get. We're only gonna call this when that's applicable. Remu just rated with 7-7. Thank you for the raid. How was your advent of code? Welcome, welcome. Betseg. Ah, we are. So I'm getting a little bit of redemption here because I spent the first, I don't know, however long misunderstanding the problem. I was actually solving part two. So I was devastated at first. Then I get a little bit of redemption because I'd already written some of the code I needed for part two. I completely misunderstood the problem. A bug missing a line of code cost me. Ah, yes, I know the feeling. Um, I'm sort of hoping that happens here because now I'm a bug collector, and I want to look at those. Sorry, I want to look at those bugs and like analyze them and be like, okay, how can I prevent myself from writing that bug in the future, or like make myself debug that faster. So the bigger list of bugs I get, and I have some tonight, then the more analysis I can perform. Um, I know that feeling. I had that happen to me a few times last year. Okay, so we're just gonna get the intersect. Let's call it li, and then we just translate this directly. So we're just gonna do like I dot min plus something plus a diff between s and d. So val diff equals s dot min minus d dot min. Am I doing that in the right direction? So if we're going like translating 50 to 100, then that's plus 50. So we want d dot min minus s dot min. And then now we just take the intersect, and this is not just a single range. So I dot min to wait I dot min plus diff I dot max plus diff. There we go. Okay, now let's look at what we're testing here. Apply range. Well, I guess other things break first. We have to fix compile errors. Overlap translations. So this is wait, a list of longs. Why are we getting longs? Oh, because we're flat mapping. So this is just a map now. So every one of those overlaps gets translated to its range of some sort. Here's a list of range. We concatenate those. We have an issue here, and then dot get, but there is an overlap there. Okay, let's. I'll bite. I'll bite. Let's look at it. Intersect of C and S. Let's test that here. Source range. So intersect. Do you write Scala in your daily job, or do you use something else? What is Scala even used for? I do write Scala in my daily job. Scala is used at, I know, a lot of companies. Um, Usually it's used on the back end for server side language. I don't know, like microservices, distributed programming. Uh, and a lot of places where you might see Java. There's also Spark. A lot of people use Scala for Spark, and it's used. A lot of the companies I've worked with that use Scala are like fintechs, or I know too many fintechs and banks or whatnot. Scala is nice for performance and concurrency. It's also nice for type safety and correctness. So if you want to make your code really safe, it has tools for that. Okay, we are testing our intersect here. So what is our intersect of this current with the source 15 to 98? This should not be empty. We'll test that before doing. We should put our diff tests, I don't know, somewhere else. Like right after the diff definition, the diff. Diff. Okay, we can put it right here. And we should put these tests. Oh, I just put it right where it was. We should put these tests here closer to the function we're actually testing. Apply range. And I guess we can test this here right below it. Option at range, none. That is not true. So the intersection here is exactly 79 to 93. So if left contains, oh, so this that I had copied over, or that Copilot thought to copy over, um, so def intersect. Oh, no, it should be something more like this. this is the function I want. R interval. You know, we're gonna rename this. I wonder if it'll know to rename. I'm gonna. Well, yeah, sure. That can be right. Right, exactly. So this is a range. We're returning a range now. And then now this becomes L. L is a range. Oh, L is a range, R is a range. Um, okay, if L is a superset of R, then some R, sure. R contains L dot min, and if R contains L dot max, then in this top case, we have a new max, which means we have the old min. So we have L dot min to this thing here. So let's just unwrap that. And then we have a new min to the old max, L dot max. And superset of def superset. Yeah, we can do this. This is library code that I am I'm not calling because it only works on ints and I'm working with longs here. I need to make this more generic so it works with any numeric type. But it should work. So L range, R range. I mean, like normally this would be over engineering and I write something up that's just what I need. And this is not a method, so we just do superset of, so L is a superset of R. This is L dot max, L dot min. This is a tongue twister to read. L dot min dot max, R dot min. Wait, L dot min dot max, that doesn't make sense. Something went wrong here. Just, oh, yes. Max is a method. Okay, yes. Yeah, it is hard to read. This is a superset. Oh wait, what? Okay, we delete this. Like maybe I should have just changed this. Uh yeah, no, I don't like this. I trust that less than I trust my own code that I've used before. Okay, so now intersect works properly, 79 and 93. Like we could do a couple other tests, like something that doesn't overlap it altogether. So like 150 to 198. And this should be empty. Right? And if we have something like really crazy, like negative 150, the whole thing, we just get the left 79 to 93. Actually, we already sort of tested that. And let's say halfway within. So let's do like 2A5L. Then we should just get 79 to 85. Perfect. Okay, great. So we can use that. That should make this work. This is now 81 to 95. Wait, is that right? Yes, that is right. That's perfect. Great. Oh, I did that again. Okay, so this is good. This is good. I'm going to comment these two out and just use our iterator. In fact, let's make sure we know the size of this. It's dot to list dot size. Next on the empty iterator. Wait, if you turn it to a list. Oh, okay. Yes, yeah. We're gonna do this. So we're gonna start with like taking 8. I think it was 9. That to list. This should give me an error. Okay, so wait, that didn't give me an error. Why did that not give me an error? Okay, so 9 should give me an error, right? This is so hacky, but you know what? It's working. So the final range take A2 list at last. And this should have some debugging as we go. Translations, yeah. So if that's not right, then we can do some debug. So 46, this works on test data. I think I finally solved it. And you know what? I should have solved it faster, like way faster. But we can adjust for that. So I'll have to do some review of myself after this. 593 593 705 72. Why don't I just copy paste? Good question. Oh my god. Okay, I'm probably still in like the top 5,000 range, which is not where I want to be. Oh boy, 10,000 on part one. But look at my delta though. I dropped 5,000 ranks there. That's because I solved part two first. Sort of. Like it wasn't completely solved, but I kind of solved part two first and then so confused. Uh, okay. Check my leaderboard. JVM is popular in fintech. Yeah, somewhat. Um, yeah, I mean, Scala's got a lot of big companies. You know, Twitter, LinkedIn used it for a while. Netflix, Gemini used Gemini. That's a fintech. They use Scala. I worked there for a while. I'm the fifth person to complete both parts. Alka got me today. Alka's doing well this year. Um, that feels all right on a list like this. Oh wait, no, other people. Java Doc got it, of course. Um, and Gupta got it. Marth. That's great. Good job, guys. I don't know if you're here or not tonight. Who is Alexander Hoff? I have not seen this name before, but they've shown up and are dominating this list. Okay, what I want to see is how did I do on deltas? Okay, I was six for deltas. I mean, I'm still happy with what I dropped. It seems like people did give up. Six for deltas, but I was 11th for part one and eighth for part two. So my delta rank is higher than my part one and part two rank. So slight bit of silver lining. Um, yeah, here's my part two code. Oh, by the way, if anyone wants to join, here is my leaderboard. And what else? I'm about to push this up to GitHub if you want to see this. Eventually, it gets cleaned up. In fact, probably tonight. Oh my god, it's so late already. It's 2:30 a.m. over here. But this is where it's going. Both both before and after I refactor. Both both versions will be in there. Um, let's look at my part one. Day 05, part one, 2023. Uh, is it just gone? Okay, you know what? Part two can generalize. I'm just gonna save this as day 5. Oh, you know what? Day 05 double sheet. I don't know what I had here. Oh yeah. This is my part one, right? Let's look at the answer. The answer should match. Um, you don't know why your part. You don't know why your part two doesn't work. I thought it does work. Part one answer. Okay, this is part one right here. Yeah, I did this silly thing so I could just have the debugging in line. I don't know. I like this. it's a lot of copy paste. It's like copy paste coding, but this is a case where like copy paste coding sort of makes sense, right? Because you could know what you're working with. Like here's a fertilizer to map, fertilizer to water map. That's what we're using right now, and you can just scroll through. I don't know. You did something manually to get the star. Oh, that's interesting. You know what? Sometimes, hmm, the intervals I was getting and try the first values. You know what? That works, and I think that's totally valid in admin code. In fact, 2021, the final problem, or I think it's like day 24, it was something where you did have to like pen and paper stuff a little bit. 2021 problem 23 was something that I actually did solve by hand. It was small to solve by hand, and that was faster than coding it up. I coded it up afterwards, but sometimes sometimes you do. Okay, so let me just do a quick walkthrough of my part two. Um, First I get the seeds, right? All these seed ranges. That's a straightforward parsing problem. And I have this helper here to extract ranges. I'm doing this in a very kind of mutable way because I have this input iterator. So when I'm doing this, I do have to be careful not to call this too many times in test code or something. Like maybe I shouldn't be doing that. When I refactor this, I'll probably get rid of that. And then I have these methods. Oh, who is that? Let's see. Oh, I have lost mine. Oh, I missed a notification, but thank you for the follow. You all saw it on screen up there. I do appreciate it, and I hope to keep seeing y'all around. This here is a bunch of library code for working with ranges. Um, I have library code written to sort of copy paste it over, but you want to get the intersection. You want to be able to like diff a range, subtract a range from another range, and you can see how that works here, right? So intersection of two ranges, you get a smaller range of some sort, either from like the left or the right. Um, 79 to 85. I don't have one that just intersects on the right, but we can do a test code here. So like let's do 85 to 100L. Right, and that should just get us 85 to 93. And then diffs, right? So you subtract a range from another range. If the range is smaller, you could end up with two ranges. So this returns a list of ranges. This is just the remaining numbers as ranges, because we can't really work with vectors of like this many numbers when we're in like the hundreds of millions. And then I have this next method, which takes my current list of ranges, and really we operate on these one at a time. So here, C is just the current range I'm operating on, and I find all the overlapping ranges by just checking if the source, for every tuple of dest and source, the source contains either the min or the max of that range. And if that's the case, then we do this apply range function, which, oh, it's so small now, I didn't even go over it. But this apply range basically just gets the intersection and then does the appropriate translation from S to D, right? And that's by taking this diff between S and D, and then adding that to the intersection. Yeah, so I get each of those. This is very general. Like, I think it might not even be the case where a range gets overlapped by multiple source ranges, but this can handle that. This can handle that if like one of my ranges overlaps with 10 different source ranges and that everything in between those and those like source ranges don't even aren't even adjacent to each other, right? So it can handle all of the missing bits in between. So that might be like over engineering, but this should be able to handle some really wonky stuff. And yeah, so once I have my next function, it's just a matter of calling like iterator.iterate. Like this just, whatever the current is, this is a loop. And we call next on the loop, we do our extract ranges. we do our print debugging that prints out like the name of the map being used. And yeah, that's it. I did I introduce an error here? Oh, it's red because of the warnings. Um, spurious warnings. I don't know. I don't know where that's coming from. Okay, so we forget about that. We don't need to worry about those. I'm gonna commit this to GitHub. Um, what is this? This is 2023. Day of 5. So I guess we have part 1. Let me just see what part 1 is. Okay, so day 05 is part 1. So I'm gonna resave this as part 1. Yes, we overwrite that. And great. So we add that, we add part 2. So day 5, this is 2023, as solved on stream. And I do want to do a review and refactor. I'll probably end up doing it tomorrow because it is late over here. Bedtime for me this month is 3 a.m. And I have like a job interview tomorrow. It's not 8 a.m. But I think I'll be fine. Okay. Whoops. But we we made it. So let me pull up the leaderboards. Yeah, good night. Try next time. If any of you are staying up, we're about to raid someone. So I'll take suggestions. Probably this late into the night we end up raiding Time Enjoyed. That's the source of all AOC, the destination. I get source and dest mixed up. That's a bug today. That's a destination of all AOC streams eventually if you just hang out long enough. In the meantime, this is the GitHub where I just push that. And if you want to chat about any of this offline, you can catch me offline at my Discord here. And again, leaderboard, if you want to push me further and further down the list, that's cool. And Twitch, Advent of Code. Who's doing Advent of Code? Time Enjoyed is, of course. Is Chi-Chi really still on? Really, like he finished it, right? Chi-Chi is really good, so I'd be like really surprised if he isn't finished. I'm gonna turn off my music for now and put on Firefox so you can hear what's going on. Yeah, I think he finished. Let me check the leaderboards.
That's the thing. Like the rest of it, the rest of it sounds fine. Like,
Chi. Yeah. Hey. Oh wait, no.
Yeah. Well, I hope it works
totally
out.
Finished.
Okay.
Let's.
I've given up on this problem. Okay. This is.
He's probably gonna call it soon. We're gonna go see Time Enjoyed. This is where we all end up.
Oh, interesting.
All right. In 10 seconds, thank you everyone for stopping by. Thank you for all the raids and watching me solve this slowly. Way behind.
Many are on the same
Here we go.
boat.
Say hi to Time Enjoyed.
Where was I? Okay, I'm gonna try.